Comparative analysis of central tendency measures. Welcome, everyone. Today, we are going to dive into a comparative analysis of central tendency measures. Now, before we look at the formulas, let's understand what we are actually trying to achieve. In the study of statistics, when we talk about a measure of central tendency, we are looking for a single, representative value that attempts to describe an entire set of data by identifying its central position. Essentially, we are looking for the heart of the data. Now you might be thinking, but teacher, I already know how to calculate the mean, the median, and the mode. And you're right, you've mastered the calculations. However, the real challenge in statistics isn't just doing the math, it's knowing which tool to pick from your toolbox. It is crucial to understand that not every measure is suitable for every type of data. If you pick the wrong measure, you run a serious risk. Choosing the wrong measure can lead to a very misleading interpretation of your data, potentially giving a false impression of reality. That is why, in this tutorial, we aren't just going to practice calculations. Instead, we are going to perform a comparative analysis. My goal is to help you understand the strengths and weaknesses of each measure so that you can confidently decide which one to use based on the specific scenario you are facing. The mean arithmetic average. Now that we've established what a measure of central tendency is, let's dive into our first specific measure, the mean, which you might also know as the arithmetic average. The mean is undoubtedly the most commonly used measure in statistics. To find it, the process is quite straightforward. You simply sum up all the individual observations in your dataset and then divide that total sum by the total number of observations you have. So, when should you actually use the mean? It is best used for general purposes, specifically when your data is distributed evenly, and most importantly, when it doesn't contain any extreme values. The reason it's so powerful in these cases is that because the calculation incorporates every single value in the dataset, it provides a very comprehensive and detailed average of the entire group. However, we must be careful because the mean has a significant limitation. It is highly sensitive to outliers. Now, remember that an outlier is just a value that is significantly higher or lower than the rest of the data, something that sits far away from the main cluster. Because the mean relies on adding all values together, one single extreme value can pull the mean away from the true center of the data. This can result in an average that is misleading and no longer truly representative of the group. We will see a perfect example of this pulling effect in the next slide when we look at some test scores. Real-world example, class test scores. Now that we understand the definition of the mean and its sensitivity to outliers from the previous slide, let's look at a concrete example to see it in action. Imagine we have a small group of 5 students who recently took a math quiz, and their scores are 80, 82, 85, 88, and 90. To find the mean, we follow a simple 2-step process. First, we sum all the scores together. When we add 80, 82, 85, 88, and 90, we get a total of 425. Next, we take that sum and divide it by the total number of students, which in this case, n equals 5. So 425 divided by 5 gives us 85. Looking at our result, we can conclude that the mean is 85. This number is a very fair and accurate representation of how the class performed as a whole, because the scores are all relatively close to one another. However, I want you to pay close attention to the what-if scenario here, which connects back to that concept of outliers I mentioned earlier. Suppose one of those students had actually scored a 10 instead of an 80. Even though the other 4 students still performed very well, that single low score of 10 would pull the entire average down significantly. This demonstrates exactly why we must be cautious when using the mean if extreme values are present, a concept we will explore further when we move on to the median in the next slide. The median, the middle value. The median is simply the middlemost observation in your dataset. However, there is one crucial rule you must remember before you try to find it. You must first arrange your data in order, either from smallest to largest or largest to smallest. Once the data is sorted, the median is the value sitting exactly in the center. So, when should you choose the median over the mean? The median is most appropriate when your dataset contains extreme values, those outliers we discussed in the previous slide, or when your data is skewed, meaning it's bunched up on one side. The real beauty of the median lies in its stability. Unlike the median is not affected by how incredibly large or incredibly small those extreme values are. It doesn't care about the actual magnitude of the outliers. It only cares about their position in the sorted list. This makes it a much more reliable measure of the center when your data is messy or uneven. In our next slide, I'll show you a real-world example involving household incomes to demonstrate exactly how this works. Now that we have seen how the mean can be easily distorted by a single extreme value, let's look at a much more robust alternative, the median. Real-world example, average household income. Now, let's put that concept of sensitivity to outliers we just discussed into a real-world context. Imagine a small neighborhood consisting of just 5 houses. If we look at their annual incomes, we see most people are earning around $30,000, $35,000, $40,000, and $45,000. But then, we have one house where the resident earns $1 million. To find the median, we follow a simple process. First, we ensure the data is arranged in ascending order, which we have already done. 30,000, 35,000, 40,000, 45,000, and $1 million. Next, we need to identify the middle value. Since our total number of observations, or n, is 5, which is an odd number, we can find the exact middle position by using the formula. 5 plus 1, all divided by 2. This tells us that the third observation is our median. Looking at our ordered list, the third value is $40,000. Now, here is why this is so important for your analysis. If we were to calculate the mean, as we saw in the previous slide, the result would be $230,000. Does that sound right for this neighborhood? Not really. That figure is incredibly misleading because, as you can see, no one in this group actually earns anywhere near $230,000. The single $1 million income has pulled the mean way up. However, the median of $40,000 gives us a much more honest and accurate representation of what a typical household in this area actually earns. This perfectly demonstrates why the median is your best friend when dealing with skewed data. In the next slide, we will shift our focus from numerical values to a different type of data, the mode. The mode, the most frequent value. Now that we have explored how the mean can be skewed by outliers and how the median provides a more stable middle ground for skewed data, let's look at our third and final measure, the mode. The mode is quite straightforward to identify. It is simply the value that appears most frequently within your data set. If you are looking at a list of numbers, you are essentially looking for the one that repeats the most. So, when should you choose the mode over the mean or the median? The mode is your best tool when your goal is to identify the most popular item or the most common category in a group. Most importantly, the mode has a unique advantage that the other two measures do not. It is the only measure of central tendency that can be used for non-numerical or categorical data. While you cannot calculate a mathematical average for things like colors or brands, you can certainly identify which one appears most often. To see how this works in a practical business setting, let's move on to our next slide, where we will look at an example involving inventory management in a shoe store. Real-world example, inventory management in a shoe store. Imagine a shoe store owner who is trying to make a smart business decision about which shoe sizes to stock most heavily in their inventory. To figure this out, they look at the sales records for the last 10 pairs of shoes sold, and the sizes recorded are 7, 8, 8, 9, 8, 10, 11, 8, 7, and 9. To find our measure of central tendency here, we follow a simple two-step process. First, we need to perform a frequency count. Let's go through the list. Size 7 appears 2 times, size 8 appears 4 times, size 9 appears 2 times, size 10 appears 1 time, and finally, size 11 appears 1 time. Second, we simply identify which value has the highest frequency. Looking at our count, size 8 is clearly the winner. Therefore, our conclusion is that the mode is 8. Now, let's analyze why this matters for the business. The owner should prioritize stocking more of size 8. If the owner had mistakenly used the mean, which would be approximately 8.5, it would be completely useless for their inventory planning because you cannot order or sell a shoe in a size 8.5. In this scenario, the mode provides the only actionable insight. Now that we have understood the concept of the mode as the most frequent value, let's look at a practical application in a retail setting. This leads us perfectly into our next slide, where we will summarize all these different measures in a comparison table. Summary comparison table. Now that we have explored the mean, the median, and the mode through our various real-world examples, let's bring everything together. I want you to look at this summary comparison table, as it serves as your ultimate cheat sheet for deciding which measure to use in any statistical problem. Let's start with the mean. As we discussed in our first example with the test scores, the mean is best used when your data is symmetrical and lacks any extreme outliers. Its main advantage is that it is very comprehensive because it incorporates every single data point into the calculation. However, as you saw when we discussed that one low test score, its biggest disadvantage is that it is highly sensitive to outliers, which can pull the average away from the true center. Next, let's look at the median. We use the example of household incomes to show that the median is your best friend when dealing with skewed data or datasets that contain extreme values. The main advantage here is its robustness. It is not affected by how large or small those extreme values are. But the trade-off is that, because it only focuses on the middle position, it essentially ignores the actual numerical magnitude of the extreme values in the set. Finally, we have the mode. As we saw with the shoe store inventory, the mode is perfect for categorical data or when you simply want to identify the most popular item. It is very easy to identify the most common value in a list. However, keep in mind the disadvantage. Depending on your data, you might encounter a dataset that has no mode at all, or one that has multiple modes, which can make it less definitive than the other measures. Keep this table in mind as we move into our final discussion on common mistakes to avoid. Common mistakes. First, watch out for using the mean when dealing with skewed data. It is a very common habit to default to the mean for every single problem you encounter. However, always keep an eye out for values that are vastly different from the rest of the group. Think back to our example of the billionaire in a room of middle-class people. That one extreme value will pull the mean upward, creating a misleading picture. In those specific cases, you should switch to the median to get a more honest representation. Second, be careful not to confuse the median with the mean when you hear the word average used in everyday conversation. In common language, when people say average, they almost always mean the mean. But remember, in our statistics class, average is a broader term that can refer to any measure of central tendency, the mean, the median, or even the mode. To avoid errors, never assume which one is being discussed. Always check the distribution of your data before choosing your mathematical tool. Finally, a very important rule. You cannot apply the mean or the median to categorical data. For instance, if you are looking at a list of favorite colors, such as red, blue, or green, it is mathematically impossible to calculate a numerical middle or an arithmetic average. In these scenarios involving categories rather than numbers, the mode is your only valid measure. Now, before we wrap up with our final summary, I want to pause and highlight some common pitfalls. Even students who understand the formulas can sometimes make mistakes in the application phase. Keep these distinctions in mind as we move into our final key takeaways. Key takeaways. All right, we have reached the end of our tutorial, so let's bring everything together with a final summary of what we've learned today. First, let's revisit the mean. As we discussed with our class test scores earlier, the mean is your mathematical average. It is a very precise measure because it incorporates every single data point into the calculation, but as you saw with the outlier example, it is highly sensitive to extreme values. One single large or small number can pull the mean away from the true center. Next, we have the median. Remember our example regarding household incomes? The median is simply the positional middle of your data. Because it only cares about the order of the numbers and not their actual magnitude, it is robust. This means it stays stable and is the ideal choice when you are dealing with skewed distributions or datasets that contain those pesky outliers. Then there is the mode. As we saw with the shoe store inventory, the mode is simply the value that appears most frequently. It is your go-to tool when you are looking for popularity or when you are working with categorical data, like colors or sizes, where calculating a mathematical average just wouldn't make sense. To wrap everything up, I want you to remember this golden rule: there is no single best measure. The choice of which measure to use depends entirely on the nature of the data you are looking at and the specific goal of your analysis. Always look at your dataset first, check for outliers, and then decide which tool is the most honest way to represent your data. Great job following along today. Keep practicing, and I'll see you in the next lesson.